I need to be careful about the way I speak here. Does energy ever get lost? Okay, so, okay.
That's the discussion I was having with her, because I said that technically, yes, the ball loses energy.
Right.
But the energy is not destroyed.
Right. So this is we talked about this a little bit. We talked about this a little bit with forces in motion. Anytime you're doing any kind of problem like this, when you're talking about forces in motion, or you're talking about energy, you have to define your system first. Okay. You have to define what you're talking about. Let's just talk about the ball. All right. The ball has a certain amount of energy. Does the ball lose energy over the process?
Yes.
Yes. The ball loses some energy. We don't lose energy in the universe. The energy just gets converted in other forms. Where does it go?
Other forms.
Yeah, what are the other forms? When this ball doesn't bounce up as high, the ball has lost energy. Where does it go? We've talked a little bit about it. Some of it goes to sound. Some of it goes to heat energy. You're heating. You are heating ground up a little bit, and you're heating. The ball actually heats up a little bit. You can say that that's still part of the energy of the ball, but it's now kind of less useful. It's not going to be able to be used for the ball bouncing. So heat's interesting. Heat is an important thing for you to grapple with, because heat, anytime we have energy conversions from one form to another, heat usually is involved. And heat is tricky because it usually, well, here's one of the rules of thermodynamics is that when you convert energy into heat, you can't get it all back. All right? Fundamentally, you can't get that heat back because it's disorganized. That's what was an interesting way of putting it, this idea of control. Heat is a disorganized form of energy, and so you can't get it all back. You can use heat to power things, but you're also wasting some of it because it's kind of a disorganized form of energy. Okay.
You haven't talked about gravity either.
Gravity, in what sense?
Well, losing energy. Because, when you're coming down, you're speeding up because of gravity. When you're bouncing away, you're losing energy because of pull gravity is pulling you back down.
But if we didn't lose energy to heat, so it's like the pendulum. Let's say that we have a perfectly elastic Superball, and we don't lose any heat. We have a magic surface here that doesn't absorb heat. If we drop this ball, it will keep us, right, forever. So you'd be constantly, yes, you would be losing potential energy, but you'd be gaining kinetic energy.
Right, but as you bounce back up, you're fighting the pull of gravity, which is pulling you down.
Right, but you're gaining potential energy.
True, but you're still fighting gravity. I mean, gravity is pulling you down. So, I mean, it's just the fact that this large mass operating on that small mass is going to be pulling it down. So you can't recapture all of it if you have a perfectly elastic ball. Unless, I mean, tell me where I'm wrong. If it bounces up perfectly elastically, you still have this 10 meters per second squared, whatever, pulling back down. That's going to.
Okay, this is a good point. It's like the pendulum. If you had no loss of the pendulum, it's the same thing. Actually, this bouncing ball and the pendulum are kind of exactly the same thing. You have something dropping, coming back up, dropping, coming back up. But let's talk about that. This purely mechanical system, you have gravitational potential energy. So you have gravitational potential energy, right? Up here. As I drop, the way of thinking about this, I'm tempted to graph it, but let me not graph it because let's just talk about it. As I lose potential energy, I'm gaining kinetic energy. And it's actually if we have an ideal case, it's exactly 1-to-1. All right? My total amount of energy hasn't changed. All right? I bounce off the floor, I'm losing kinetic energy, and I'm gaining potential energy, and I get back. So my total energy doesn't change at all during the whole process. It's just being converted back and forth into potential to kinetic, potential to kinetic. In the real world, there's something sucking away that total energy, and it's heat and sound. Okay, so I eventually, we can see that happen here. Boom. We don't get that perfect conversion back to kinetic potential energy because it's going away into other. It's leaking away into the universe. That energy that we just released. Okay. All right. I think that's all. We really have the discussion on this. Unless people have other things we want to talk about, we can start working on our round robin.